Welcome back, Section 7-2 Trigonometric Integrals. Sometimes we need to use trigonometric identities in combination with other techniques to evaluate integrals of trigonometric functions. For example 1, evaluate integral sine power 3x dx, so sine cubed x dx. Here we are going to use the identity cosine squared x plus sine squared x is 1. Why? This identity in turn gives us the identity sine squared x is 1 minus cosine squared x. So that's useful, right? You will see how. Integral sine cubed x, that's the original question, is integral sine squared x times sine x dx. So I split the 3 as a power of 2 and a power of 1. Now that power of 2, we are going to replace it by 1 minus cosine squared x. So integral 1 minus cosine squared x times sine x dx. So why did we do this? Now we can use substitution. Set u equals cosine x. If I use u equals cosine x, then derivative of u is going to be negative sine x dx. That's why. So 1 minus u squared and du is negative sine x dx. So positive sine x dx is a negative du. That's where the negative comes from and the du comes from. So get the negative out. Integral 1 minus u squared du. Now this is a straightforward integration. Don't forget the negative. Integral 1 is u. Integral u squared is u cubed over 3. And a negative continues plus a constant of integration. Negative u being cosine x, negative cosine x minus cosine cubed x over 3 plus constant of integration. Negative cosine x, positive cosine cubed x over 3 plus constant of integration. Alright, so that's integral of sine cubed x. So remember, when you had an odd power of sine, you take one of the signs away to get your du. The even power of sine, you can replace it by an expression of cosine. Let's play the same game again. Evaluate sine power 7x cosine squared x dx. So that is an odd power of sine. Sine to the power 7, I'm splitting it as sine squared power 3 and sine. You see what I did? Because of power 7, I removed one of it away and I'm left with 6 powers of sine. 6 powers of sine is nothing but third power of sine squared. Now I can use the same substitution as before. Sine's identity, that is sine squared is 1 minus cosine squared. Power 3 is power 3. Cosine squared from the question continues sine x dx. Now we are safe to ready to use the substitution. U equals cosine x 1 minus u squared power 3. Cosine squared is again u squared. Sine x dx is negative du. Remember, u is cosine, so derivative will be negative sine. And therefore, I have an extra negative here. So bring the negative out. Expand this cube power. 1 minus 3u squared plus 3u to the 4th minus u to the power 6. Okay, check my work. Don't forget there is a u squared outside, du. Distribute the u squared. So don't forget the negative. Integral u squared minus 3u to the power 4 plus 3u to the power 6 minus u to the power 8. That's distribution of u squared. At this point, we can go on to take integral. Don't forget the negative. Integral of u squared is u cubed over 3 minus integral of 3u to the 4th is 3u to the 5th power 5 over 5 plus integral of 3u power 6 is 3u to the power 7 over 7 minus integral of u to the 8 is u to the power 9 over 9 plus constant of integration. Don't forget the negative outside. U is cosine. We simply rewrite the question in terms of x's because the question was in terms of x, so your solution must be in terms of x. U is cosine, so cosine cubed x over 3 minus 3 cosine power 5 x over 5 plus 3 cosine power 7 x over 7 minus cosine power 9 x over 9 and the constant of integration. So I hope this is clear. When you have an odd power of sign, remove the one of the powers out to make it odd, at least 3 or higher, of course. Remove the one sign and the remainder can be converted to some form of expression of cosine. Okay, so we'll continue next in our next video.